Okay, so hi everybody. Dobre wieczór, Warszawa. I hope that was not too terrible. Sorry if it was. So my name is Ramon, and for the next 30 minutes, we're going to be talking about why you might not need classes in JavaScript. But before we get into that, let me talk a bit about who I am. So I'm a front-end web developer from Madrid. I work at a startup called Undefined Labs. We build developer tools to help teams ship better code faster. We're currently working on a tool focused on testing visibility. It's called Scope. If you want to know more about that, you can go to scope.dev. As it has been said, I work with JavaScript and React, and I really like them. But above, I really love the web in general as a platform. I love its promise of an open medium that is accessible to all, and I really like the development community around it as well. I think it's a very nice one. And it's partly why I like to go to conferences like this one and give talks. I also volunteer at a lab, which is a coding bootcamp for women in Madrid. So you probably can already tell I care quite a bit about community and inclusion in our industry. So let me take just a minute to say that one of the things I would really like to see as part of that, those community and inclusion efforts, is conferences stepping up their game when it comes to these issues. So things like having an enforceable code of conduct, or so that everybody can feel safe, or making an active effort to feature more diverse more diverse speaker lineups. And that's, some conferences are, or thank you, some conferences already do this, and that's great, but I would like it to become the norm rather than the exception. And you as attendees have the power to change it, because you can demand these things from the conferences you would like to attend. So let's see if we can do better in the future. All that being said, let's get on with it. So what are we going to discuss today? First, we're going to see why we got classes introduced into the language, to give you a little bit of context and history about that. Then we'll take a look at common issues and pitfalls that you might bump into when working with classes. Then we'll go on to check some alternative patterns to using classes. And finally, we'll review a couple of recent cases of popular JavaScript frameworks that are moving away from classes. So you can see that I'm not the only one crazy about this, and there's actually community moving around it. So why did we get classes in the first place? Well, classes were introduced into JavaScript over 4 years ago now. They were part of the 6th edition of the language, known as ECMAScript 2015, as you probably know. And when you think about classes, you tend to think about object-oriented programming, right? But it turns out that, as you probably know, JavaScript already had a mechanism for object orientation. And it's been right there in the language from the very beginning. It's the prototype. So if we already had prototypes, then why did we get classes again? Let's look at an example. Here's a simple counter written using prototypes on the left and classes on the right. We are going to be using this example on the talk, so you can take a look, but it's fairly simple. It just gets an initial value in the constructor, and it has methods to increment the value and to reset it. That's it. And so in this comparison, the class looks a little bit cleaner, but it's not such a dramatic difference, I'd say. However, when you try to do inheritance with prototypes, things get much uglier and messy pretty quick. So here's now a step counter that inherits from the counter we saw before. It's basically the same thing, but now we get the step of the counter as a parameter. So we are overriding the inc method to increment. And as you can see, we have to do some pretty weird stuff with prototypes on the left, whereas with classes, we just use the stance keyword, and we call super in the constructor, which is much nicer. It looks familiar. So based on what we just saw, we could say that we got classes in JavaScript as an improvement over prototypes, at least in terms of syntax. But there's probably a more important reason, I think, and it's that classes are familiar for new people coming to JavaScript from other languages. Because I don't know if you've heard, but JavaScript has become quite popular in the past few years. So introducing something like classes, it's a very common concept in other languages, seemed like a good idea. So classes don't seem so bad, right? Like there are legitimate practical reasons to have them in the language. As we've seen, they're better than prototypes, nicer to use. So what's the problem? What are you talking about? Well, there are actually a few problems. So let's go over them. The first and most important one for me, and it would be like the one thing I would like you to remember from this talk, is that classes in JavaScript create false expectations. We just said that a reason to add classes to the language was because they are a familiar concept. But the thing is that classes in JavaScript are not at all like in other languages. So we are using the class word for something that doesn't really quite behave as you would expect. Let's see an example of this. So going back to our counter class from before. Let's say we are creating an instance with 0 as the initial value. And if we call the increment method and then we print out the value, sure, we get 1. That worked out. But what happens if I now do this? So first, as you might know, classes are in JavaScript are basically syntactic sugar over prototypes. So first notice how I can actually access the underlying prototype. I would call this a pre-leak abstraction. But besides that, the thing is that the prototype is a living object that is referenced from other instances. So if I change the prototype like that, even though the counter instance was created before we changed it, it is affected anyway. And now we call inc, it is subtracting instead of incrementing, and the value goes to 0. So this doesn't quite match the expectations people have about classes in general. And that's the thing. Typically, a class defines a type that can be later instantiated at runtime, whereas a prototype in JavaScript is a living object instance itself, that is then referenced by other objects. And living is the key word here. Unlike classes, definitions in JavaScript are not statically copied at declaration time. So, as I said, the prototype is an instance itself. So you can modify them, and the changes you make to it will affect previously instantiated objects. And since classes are syntactic sugar over prototypes, they behave this way as well. Besides that, also notice in the example that we just saw that I can access the value field of the counter from the outside, which is something that we might probably want to avoid. We might probably want to have the value as a private thing and then call the increment method to actually use the counter. But then again, this is another issue with classes. They lack many features that you have in other languages. We don't have private members, we don't have static members, we don't have decorators. There are proposals for all these things, but they are not part of the standard just yet. And they will likely take some time to land as they're tricky to implement on top of prototypes. And to be honest, I'm not even quite sure that we want or need some of these things, like take static methods, for example. Okay, they make sense in languages like Java, where everything needs to be a class. But in JavaScript, you can define a standalone function and use it from wherever you need, including from inside a class. There are some use cases for static methods in JavaScript classes, but they are not as important as you might think. So we are trying to shove them into a language that it wasn't really thought that way. And then there's the context binding problem. Handling the this keyword in classes is really confusing and error prone. And these kind of context problems show up with asynchronous code, which is basically everyday's code in the browser, so you bump into this all the time. Let's say we have a button class that just gets a click handler. It only does that. So we instantiate a counter, or the counter from before, and we use its increment method as the click handler for the button. So the idea here is that whenever you click on the button, the counter is incremented, right? Well, it turns out that the counter is not actually incremented. And not only that, but if we look at the button instance, we see that it has a value property in it that is not a number. As some of you might already know, what happened is that the inc method of the counter uses the this keyword inside to add 1 to its value. And since we are passing the click handler to the button in this line right here, the keyword, this keyword in this line is actually the button, not the counter. So button.value is undefined, undefined plus 1, not a number. So what we need to do to avoid this is bind the inc method to the counter instance. We can do that on every call, either with the bind method or with an arrow function. But this is error prone. We have to do it all the time. We might forget it. So OK, we can move it to the constructor of the counter class. This is safer. We're not going to forget. We'll need to do it once. But the syntax is not very nice, arguably. But there's no problem. We have a class fill arrow function proposal that lets us do this, which is exactly the same. The syntax is neither, sir. OK, we are fine. But still, the problem is that no matter which way you do the binding, if we now look at the prototype of the counter, we are going to get the constructor and the reset method, but we are not to get the increment method, because the increment method is no longer a class method. It's an instance property. It's added to every new instance in the constructor in runtime. We just saw that. We are doing this in the constructor, which is the instance.increment, and we are assigning it to the inc method defined in the class, bind it to the instance. So we are overriding that thing. It's now an instance property. It's not a class method. So again, classes are supposed to be a blueprint, and instances are supposed to reference the class methods, at least in most other common languages. But here, we are effectively creating a completely brand new function for every instance. So that's not much in the expectations you would have with classes again. And there are also performance implications related to this, but I'd say they're very minor compared to other problems. And finally, classes are harder to deal with for tools. They don't minify very well, which results in larger bundle sizes. Method names cannot be safely minified. Most minifiers basically leave them as they are. And things like automatic dead code removal of class methods. That's not easy at all. Whereas with functions, removing unused functions, it's much easier. Classes are also not very friendly to some advanced techniques either, like they make ahead of time compilation harder, and things like hot reloading pretty unreliable. So we've seen all the potential problems classes in JavaScript might have, and we might want to avoid them. But surely we don't want to go back to using raw prototypes, which they are the same thing under the hood. So we wouldn't really be gaining anything. So then what's left? Well, what's left are just functions. We can take advantage of core fundamental features of JavaScript, like closures, to do similar things to what we do with classes, but only with functions in a different way, but the concept is the same. We can even emulate object-oriented programming that are typically object-oriented programming features that are typically implemented with classes, like inheritance, encapsulation, or polymorphism. And we can also implement common design patterns like factories or singletons with functions. We're going to see examples of this. So let's take a look at how we can leverage closures in particular to do these things. First of all, closures help with encapsulation. So here we have the counter, the class counter from before, rewritten as a create counter factory function, which is a function that returns an instance, basically. And we can notice a few things right away. First, we don't need to save the initial value in the instance. Due to the way closures work, we can just access it in the reset method that we are returning, and it will be binded to it. And also, the counter value that we couldn't make private, it is now effectively private, because we are just, in this closure, we are just defining a constant, and we assign it a value, and we change it. And that's it. We actually need to return a getValue method to gain access to the value if we want it. But otherwise, we cannot access it from the outside. So, and one thing that you might be thinking is, sure, but now we are creating new objects all the time. There's no references. That performance gain that we get from classes is lost. And you're right, but that already happened when we had to bind a method in a class. So I don't think it doesn't look like such a horrible trade-off, because in return, we get private members, and we avoid issues with a this keyword. This is the same thing as the class button, but rewritten with a factory function. And we don't need to do any binding. We don't need to do anything. It just works, because closures gives us implicit binding. And as you can see, we can now do the create button. We can now call the create button function and pass the increment method, and everything works as you would expect. So these are basic closures. Object composition, it's another powerful concept that we can use. It can help us implement equivalent patterns to inheritance or polymorphism with a different thinking model, but it's more or less the same. So here we have a create base counter function that is almost like create counter, but instead of the increment method, it has a set value method. So this would be like our base factory function, on top of which we'll be defining the actual counters we're going to use. So based on that, we can create a step counter, create a step counter function. And what we do is just we call create base counter, and we get every property but the set value, because we don't want, if this is the step counter, we don't want to expose the set value directly. What we want to do is use it internally in our increment method and then expose that. So this is somewhat inheriting from the base counter, and we don't need to do it with classes. Another way to do something very similar. And then we can have our basic counter, and we can, in this case, in the increment method, add 1, or we can even define our counter based on the step counter, passing just an argument. Then you can mix and match with different functions, which is something that functions really easily lend to composition. Talking about which, function composition and patterns like higher order functions and some other resources that we have in this functions toolbox. And we can use them to implement patterns similar to decorators of mixins. Like this example, it's a higher order function, which is nothing else but that a function that returns another function. So if we are getting a method, and what we're doing is return a new function that console logs the arguments and then calls the original method with those arguments. And we will use it like this. We just have our method, and we pass it with login, and we get back our decorating function. It's more verbose than using the add syntax of a decorator in classes, but the point is that it works. You can make it work. And finally, modern JavaScript, we also have modules. They provide encapsulation again, and they can help implement some design patterns. For example, a singleton. This is all you need to do a singleton counter based on the one we wrote before. So notice that the only thing this module is exporting is the create singleton counter function. And then we have a constant that is private to the module called instance. And all that we do when we call create single counter is, if we don't have an instance yet, we create one and assign it to the instance variable. And if we do have the instance already created, we just return it. And that's it. You can do this with classes, but you can look for some examples online, and it's a little bit, let's say, it's not pretty. You can do it, but it's not as straightforward. OK, so we've seen the problems with classes. We've seen some alternative patterns. But as I was saying at the beginning, is this something that I'm just coming up with? Is really something happening around this in the community? Well, there is. There are actually examples of very popular JavaScript frameworks that are moving away from classes. Probably the one that everybody thinks first is React and its hooks. React already had a class-based API to define components. And one of the problems was that you had to convert from the function-based syntax to the class-based one whenever you needed to add state. That was a pain in the ass. So they came up with the hooks. This is how they look. It's really not important, but just so you get an idea, React provides this useState function that you call, and it returns a value and a setter, basically, and you use it in your code. And notice that since this is not a class, everything is in the same closure. So we don't need, with the for example, we don't need to bind the increment method on the button on click listener. We don't need to do any of that. We just use it. Whereas in a class, we would have all these things in different methods, and we would need to be doing the binding thing with this keyword that we saw before. And then there's an interesting example, which is Vue, because Vue didn't have a class-based API. And the really interesting thing about them is that there was actually a proposal for a class-based API for Vue that was actually dropped in the end in favor of what they call the Vue Composition API, which is heavily inspired by React hooks. So they themselves realized at some point the problems that the classes were introducing in the framework, and decided to completely drop the proposal in favor of something more function-based. So this is how the Vue version of hooks works. Is really similar. We have this Vue reactive thing to tell you that this is a value that we're going to be modifying, and then you use it on your template. Very similar thing. So, what have these frameworks? Why have these frameworks decided to move away from classes, and what is it that they found out that it didn't work quite well? And as I said, it's particularly in the case of Vue, because they actually considered it and decided not to go with it. Well, one of the things they realized is that classes mix concerns. So using function-based APIs leads to better logic organization. If you have, for example, a component that needs to add an event handler to the DOM and then remove it when it gets ammounted, in the classic example of React with the class-based API, you have the component inbound method and the component will unmount method, and you have to write the add event listener line in one, and then the remove event listener line in the other one. And but it's the same logic. It's like what you want to do, what you would like to do is to have all the logic related to this event handler in the same place. But you need to scatter all your logic around the component, because it isn't grouped by logic. You can't do that. You cannot do that. You have to group them by at which point in the life cycle they happen, and that's a pity. So the good things about patterns like this is that you can actually extract functions with code grouped by feature, not by life cycles. If we go back to the Vue example, you look in to the setup property, all that's inside that it's just they're just functions and objects. Like there are no classes, no methods, no this, nothing. You could just take that piece of code, move it out of the counter, and give it a name, and just call it from the setup. And you could move it to a different file and call it from a different component. And that's the power of it, that you get all your logic encapsulated, and you can reuse it in a simpler way. And actually, the reusable part relates to the next point, and it is that function-based APIs lead to less convoluted patterns. Because again, if you want let's say we want to, in this example of the event listener that we add and remove, let's say we want to reuse that between different components. Well, what we have to do would be to use patterns like higher order components or mixins. So basically you've had a component that does something in component in mount, does something else in component in mount, and what do you render? You are abstracting away logic, but you don't really want to render anything. So you need to make this component get another one and paint it, or maybe use render props. Like there's all kinds of really complicated patterns that are useful when you learn them, but at first are like really hard to understand. Those kind of patterns also are more difficult to follow, because if you have a bunch of decorators, a bunch of higher order components, the sources are unclear. You don't know which props are coming from which decorators, and you can even have namespace classing. So that's a problem. And again, following up on this, function-based patterns are more type-friendly than class-based one. Because as we saw, we are mostly using plain variables and functions. So they are easier to type manually, and also type inference works better, either with TypeScript or Flow, because they're just easier patterns. Whereas with things like higher order components, you need to define the props, the types of the props that are actually your component, and then the ones that the higher order component is injecting. And it's, if you've ever worked with that, you know what I'm talking about. It can be quite messy to do. So these would be like the three specific things they found out related to moving away from classes in frameworks, in front-end frameworks. This is, of course, in addition to all the problems and benefits we've seen before, like bundle sizes. The function-based components are minified better than class-based ones. Okay, so that was a lot of stuff. So let's do a quick recap of the main points we've been talking about, so you can at least remember something tomorrow. So first off, and most important one, I said it before, adjust your expectations with working with classes in JavaScript. I am not saying you shouldn't use classes, but you need to take into account that they do not work as in other languages at all. And you need to be familiar with prototypes behind them. And that might be okay if you're a JavaScript expert or you are really focused on the front end, but if you have a diverse team and you have people coming from maybe a backend background and they are coming from Java, they might think classes are familiar at first because they do look familiar, but then they will bump into these binding issues really quickly and they will be extremely confused about it because it's just not the same mental model. So functions are, in a way, simpler. So even if you use classes, you need to adjust your expectations. Then watch out for issues with context and the this keyword. Remember to bind your methods when dealing with asynchronous code. I do know about this, and to this day, it still happens to me every single day that I will forget to bind that method. So that's a thing. And also look out for encapsulation issues if that's something that concerns you. What we seem we might want to use Bubble with some plugin to have support for the upcoming things, the private members and stuff. And finally, unless there are performance concerns, like actual real performance concerns, you have tons of instances, which is not the case in 99% of the apps. Or unless your framework of choice impose classes, which is less and less common, I would suggest to consider using functions. Maybe not all the time, but at least every time you're going to write a function, you might want to consider if you really need to do that. Having things like closures, modules, object composition, function composition, they are all powerful concepts, and they feel very natural to the language. And specifically things like closures, that a lot of the alternative patterns we saw are based on closures. And closures are, in fact, so fundamental to the JavaScript language that you're going to have to learn them anyway, even if you don't know them quite well. So since you're learning them, since you have to do that, you might as well take full advantage of them and try to use them. And to be fair, it's also a lot of fun to use functions and to compose things. So that's like, it can spice things up as well. That's another benefit. So that was all on my part. Thank you.